we begin review linear algebra. So the system of equation, as you see in this class, there will be a lot of different ways to solve the system of equation. But the best way, the most efficient, is to use a calculator and turn this into a reduced row echelon form. But first, we put it in a numeric matrix with all the coefficients on the left hand side: 1x1, negative 1x1, 3x3 equal to negative 8. 2x1, 0x2, 1x3 equal to 0. And 1x1, 5x2, and 1x3 equal to 40. And we'll do reduced row echelon form. In this review, there will be problems where we will do this process by hand, but for now, we just use a calculator. Right, so second x to negative 1, second x to negative 1, and then go to math, go down to option B, says REF, reduce row echelon form. And then we're going to put the matrix alpha zoom. This matrix has 3 rows and 4 columns. Right, we just enter the numbers in the matrix. Notice when we do this, we do not hit enter until we're done. Always use these arrows to navigate the matrix. Don't use the enter. And also, this is the subtract sign between two numbers. We use the negative if it is in front of a number. Alright, so 1, then next, negative 1, next, 3, next, negative 8, 2, 1, 1, 5, 1, and 40. Right, so we have that. So originally we have coefficient for x1, x2, and x3 in column. So we have x1, x2, and x3. And each column we have the 1 in the pivot for the column x1. So we have x1 is 0, x2 is 8, and x3 is 0. Or we just write this x1, x2, x3 equal to 0, 8, and 0. We can write that as a triplet, or the triplet, or a vector later, but any form will be fine. Right. Now go to next one. We'll do the same thing. Put this in a numeric matrix and then do reduce row echelon form. 5 to 1, negative 11. 2, negative 3, negative 1, 17. And 7, 1, 2, negative 4. Right, again, second x to negative 1 or second matrix. Go to option B, alpha zoom, 3 row 4 columns, so that's good. Right, 5, 2, 1 equal to negative 11, 2, negative 3, negative 1, and 17. 7, 1, 2, and negative 4. Hit enter. Right, so that's what we have. once again we have x1 has the pivot at x1, pivot for x2, pivot for x3, so the solution will be 0, -6 and 1. Right. Next we have an application. Ceramics workshop make three types of items: bricks, trees, and slates for sale. Right. So we have three times, and so the process we have to prepare, to paint, and then to fire. So three process. And the question here is how many of each can be made. So there are three types. So we have bricks, trees, and slate. So we use W, T, and S for those items. And then the process will be three process: prepare, paint, and fire. And the limit will be the workshop have 135 hours of prepare time, 87 of painting time, and 126 of firing. So those are the total. So we will set up the equation like this: for prep, red take 3 hours to prepare. So now focus on red take 3 hours to repair. So each one takes 3 hours. So multiply by 3. So that is the total prepare for reds. And then a tree will take 16 hours to prepare. So 16 hours for each tree. And the slate take 4 hours to repair. And the total hours is 135. Next, to paint red take 2 hours to paint. A tree take 3 hours to paint. And a slate 17 hours to paint. And the total hours is 87 hours of painting. And then firing nine hours for each graph. For a tree, 4 hours to fire. And a slate 7 hours to fire. The total time to fire 126. Now in real life, we don't really have this type of problem. Of course, most of this written by demand and by profit, so we don't have the price to reduce each item, so it's not realistic. And also, let's say in real life we might have 135 hours to prep, but in reality is this should be less than or equal to, because we might only need to use 134 hours and we have an extra hours to match with whatever it is. So the thing is 135 here is the total hours we can make. In real life we might not use all of them. Right. Ideally, if we use all the hours here, that would be perfect. Right, now, so of course we have those system of equation. Now we set up the matrix and then do reduce row echelon form. 3, 16, 4 equal to 135. 2, 3, 17 equal to 87. 9, 4, 7 equal to 126. And we just do reduce row echelon form. Right, so as you see, if you hit enter at any step, it will get out of it. So if that happens, just go up, highlight it, and just continue where you mess up. So 135, don't hit enter button, hit next instead. Right. Okay. I actually had 135 in front of it, so highlight it. Okay. So this really messed up. Let me do that again. Okay. Right, only hit enter when we're done. So 1 0 0 0 1 0. Right, as coefficient we have W, T, and S. So we have the solution. So there will be 9 W, 6 trees, and 3 sleighs. Right, so we have that. Right, the next 3 problems we'll go over quickly. Determine whether the matrix is in echelon form, reduced row echelon form, or neither. So echelon form is where we have the pivot aligned in the steps, so going down to the right. So those are the first non-zero entry. It aligned in the echelon form. So this is an echelon form. It's not quite reduced, because reduced, the top number have to be 0 as well. So we only have one pivot. This non-zero entry is 1, everything else is 0. If that is the case, that will be reduced. This one is not, because we just have the echelon form. So the next one, we have the pivots here, here, but the 3 here, that's supposed to be 0, because the next pivot have to be going down to the right. So the pivot have to be here. It cannot be on the same column. So this is neither, because this is supposed to be 0 for it to be echelon form. This one, we have the pivot here is good, everything in that column is 0. The pivot here is good, everything in that column 0. And here we don't have the pivots for these two columns. So this is in the reduced row echelon form. So that's all we have. Right. Now, use Gauss-Jordan elimination to find the complete solution to the system or state that there's no solution. Right. So once again, this one we still use a calculator. There will be a problem where we do all of this by hand, but not on this one. On the test, I will specify which one you have to do that by hand, but for now, just use a calculator. Right. 5, 2, 1, 2, -3, -1, 17. 7x, -y, and 0z. Notice the way they write that, we have to write a coefficient for x, for y, for z. Right. Reduce row echelon form. Right. We can change to fraction. Right, so this is what we have. Right. So this is what we have. This is of course in the reduced row echelon form. But what we have here is a row of 0, except for the last one is 1. So in this case we say if we have the pivot on the last column. So if we have the pivot on the rightmost column, we're going to have no solution. Simply because if we rewrite this, we have 0x. If we rewrite the system for this last row here, we have 0x plus 0y plus 0z equal to 1. Of course, if there's no x, no y, no z, it cannot equal to 1. So when we have this, that is no solution. We say pivot on the last row, last column, sorry. Of course, when we prefer last, we go from left to right, and the rightmost is the last one. So if we have pivot on the last column, that's no solution. Right. Same thing on this one. Of course, that should be -1. (2x, 0y, 3z equal to 14). Right. Reduce row echelon form. Right, so that's what we have. 1, 0. Of course, we can should change this to fraction. Hit math and then enter 2 times. Again, go to fraction. Right, now notice in this case, different than the last one, we have the whole row 0, which is perfectly fine. Now let's focus on the pivot. The pivot is here and here. So now if we have the variable x, y, z correspondingly, so we have the pivot on the x column, so we say x is basic, 1 on the y column, so y is basic as well. We don't have that for z. So in this case we say z is a free variable, y and x are basic. So we'll continue from here. We say no pivot on the z column, so z is a free variable. Right. Now from the top equation we can write 1x plus 3 over 2 z equal to 7. From here we can solve for x. Equal to 7 minus 3 over 2 z. For this equation we get y minus 1/2 z equal to 0. So we can get y is equal to 1/2 z. So we have the equations x, y, z equal to x is this. Y is 1/2 z and z is just z, a free variable. We can write this for any z. Right. So this is infinitely many solution because we have a free variable. Right. So next, now we just have, suppose the matrix is in this form. How do we write the solution? Well, let me write the timestamp first. Yeah. There's a timestamp in the description below. So just click on that to go straight to the question that you want. Right, 9, 10. So this is kind of like what we did before. We have this row and the pivot here and here. The pivot on the last column. So that is, we say pivot on the last column. So that would be no solution. Right. Next one, we have the pivot here and here. Whole row 0 is perfectly fine. So let's assign x, y, and z for it. So in this case, x is basic, y is basic, z is a free variable. So from the first equation, what we get from this is x plus 6z equal to 7. So if we want to solve for x, we always solve for the basic variable in terms of a free variable. So x equal to 7 minus 6z. Second equation, we have y minus 2z equal to minus 2. So y equal to minus 2 plus 2z. Right, so the solution, infinitely many solutions. X is 7 minus 6z, y is negative 2 plus 2z, and z is z. For z, I should say it. The solution for any z. Right. Timestamp. Right. Now we have to do this by hand. Transform the matrix into echelon form, and we're going to show all the steps. So echelon form, the way the book defines is where we have the non-zero entry like that. So we don't have to have 0 on above the pivots. So pretty much wherever the pivot is, everything below that will be 0. That will be enough. And the way the book defines it, the pivot entry doesn't have to be 1 as long as it's not equal to 0. So that's good. So what we have here is, look at the first matrix here. We have the pivot. Just going to put here. So that's one's good. Everything below that needs to be 0. So now the pivot is on the first row. So we're going to pivot based on the first row, eliminate those entries. So to eliminate the negative 3, we're going to take the opposite to that. Since we eliminate row 2, we add and replace to row 2. Same thing, we use the opposite number. And since it's just 1, so we choose 2. Based on the pivot, row 1, and we will add and replace in row 3. Right. So, of course, we're going to do this by hand, and now I'll also check by the calculator. Right. So when we do this, row 1 will stay the same. Now row 2 and row 3 will change. Row 2. 3 times 1 is 3, minus 3 is 0. 3 times 4 is 12, minus 11 is 1. 3 times negative 2 is negative 6, plus 9 is 3. 3 times 3 is 9, minus 5 is 4. Right, next, 2 times 1 minus 2 is 0. 2 times 4 is 8, plus 3, 11. 2 times negative 2 is negative 4, plus 4 is 0. Negative 2. 2 times 3 is 6. Minus 3 is 3. Right, let's check with the calculator before we go further. So first I'm going to enter the matrix. Alpha zoom 3 row 4 column. Right, so 1, 4, negative 2, 3, negative 3, negative 11, 9, negative 5, negative 2, 3, 4, negative 3. right? When we enter, don't hit enter here. What I do is hit the store button, STO key here, and then second matrix, see names. On the first one, just hit enter. So I will store the matrix we enter into the matrix A. Right, so what we do is do this operation. That means we multiply 3 to row 1, add and replace to row 2. So in the calculator, a syntax for that is going to be multiply row and then add. In particular, multiply 3 into the matrix A, that row 1, and add replace to row 2. So that's what we're going to enter. And then the next one, row and add. This time we multiply by 2. Notice, if we're going to use A again, it will apply to this matrix. What we want to do is apply to the last entry, so we're going to use the answer instead of the A. Multiply row 1, add, replace the row 3. Right, so we do that. Now this operation is in the calculator under matrix, pretty much where it is reduced to echelon form, yeah, which is here. Now what we do is multiply. So first multiply 3, second matrix, apply to matrix A, multiply to row 1, add and replace to row 2. Right, notice I forgot the plus here, so that's very important. Let's try that again. So multiply 3 to matrix A. Okay, let's add. Multiply to row 1, add and replace to row 2. Right, enter. Okay, now next, multiply to a row, add and replace. So we multiply 2. Notice now we no longer apply to matrix A, we apply to what we have here. So to get to the answer, the last answer in the calculator, use second as, right? And now add and replace, multiply to row 1, add and replace to row 3. Right, so that's what we have. Right, so let's check. So the pivot here is good, everything below that's 0, which is good. Now the pivot here is good, but this needs to be turned to 0. So all we need to do is just use the opposite to that number. Based on the pivot now is on row 2, and we add and replace to row 3. Right, we'll do by hand first, then we'll check with the calculator. And also, I think the calculator that has it has an option of, I think by default it will turn off after 6 minutes. So whatever we do, just don't leave it like that for more than 6 minutes. It will turn it off by itself, and the memory might be loose. So I just careful with that. So row 1 and 2 will stay the same. Right, negative 11 times 0 add to 0. Negative 11 times 1 plus 11. Negative 11, so that's negative 33. And negative 11 times 4, negative 44, plus 3, 41. Right. So let's check. The pivot here is good. Everything below that 0, yeah, pivot. So that's good. This is not equal to 0, so that's good as well. Right, so that is that. Let me just do this quickly. Right. So we multiply negative 11 to the matrix A. Remember, don't do that. -11 to the last answer, second negative sign, multiply 2 and add and replace to row 3, right? So this is what we have. Right, now the calculators have an option of echelon form. As we mentioned earlier, there is the reduced row echelon form and then echelon form. If we apply this to the matrix A, and you see it look different now. The way the calculator understands it, the pivot, let me change to fraction so it's easier to see. The way the calculator show, it has to be have 1 in the as the pivot, but in our book the way we define the pivot is something is not equal to 0, so we don't have to turn this into 1. Just gonna keep it like that, and of course it might be different than that. The reduced row echelon form is unique, but this one is not. So, but that's what our answer is. Right. Next, what we have is we're going to turn this matrix into a reduced row echelon form. And on the test, when it says show on step, that means you have to show on your steps. Right. So the pivot 2 is good, but if we can get 1 on that would be much better. So I'm just going to swap the 2 row 1 and row 2 swap. Swap 1, 0, 1, and 2, 2, 1, 1, and 10. 3, 2, 2, and 17. Right, so we have the pivots here. Just need to turn that to 0 and that to 0. So I'm going to use the opposite to that number. Multiply to the pivot. Add and replace to row 2. And then -3 times the pivot. Add and replace to row 3. Right. So if I'm going to use a calculator, I'm just going to type that in as a matrix A, and I'll just proceed from there. We don't have to do that and then swap row, right? So this way, I'm just do strictly using the calculator. Of course, we can do that by hand as well. But right. So first the matrix alpha zoom 3 row 4 column. Okay. Just going to enter this 1, 0, 1. Two, 1, 1, 10. Right. 1, 0, 1, 2, 2, 1, 1, 10, 3, 2, 2, 17. Now if we hit enter, that's what we have. Now let's check. If you hit second answer, of course that's the last matrix we have. So again, second answer. So by this process, we don't even have to store that into A or B. Just store the matrix, hit enter. It will store to the answer, the last answer. that will enter. So that's much better than to have to store that to somewhere, right? Now the first one we do going to do this too. With math, multiply and add. So multiply -2 to the answer matrix to row 1, add and replace to row 2, right? Then we do another one, multiply by -3 to the answer matrix to row 1, add and replace to row 3. Right, so we have that. Just going to write the result. Right, let's check. This is reduced row echelon form, so we have 1 good, 0 good, 0 is good. Now the pivot here is good. We just need to turn this to 0 and this already to 0, so that's good. So we only need to do -2 times the pivot now is in row 2 and add and replace to row 3. Right. So of course we can hit second matrix and then do all of that, but the lazy option is just hit second, enter, it pull up the last entry, so we don't have to go over all of that. Again, second, enter to pull up the last entry. Multiply -2 to the answer matrix, multiply to row 2, add and replace to row 3. Alright. So that looks good there. Right, let's check again. The pivot is good, 0 0, that's good. Next column is also good. Now the pivot here is good, but this need to be 0 and that need to be 0. So we only need 2 more. To eliminate this, we're going to use opposite to it. Multiply to the pivot now is in row 1, row 3. So we add and replace to row 1. Now use opposite to this. Multiply to the pivot row 3, add and replace to row 2. Right. So again, you can hit second matrix and then go to math and then choose that, or just hit second, enter if the operation is still the same. Now this time we multiply -1 to the answer matrix, multiply to row 3 and add and replace to row 1. Right, so we have that. So that's 1 0, which is good. Now this needs to be 0, so just need to multiply 1 to the answer pivot row 3, add and replace to row 2. So that's what we have. Right, so this is in the reduced row echelon form. We have the pivot, and the pivot is the only non-zero entry in that column. Right, so that's what we have. Right, next one is a lot easier. Let u be this vector and that v that vector. Now just do the linear combination of 2u plus v. So 2 times the vector u plus vector v, 2 times 5 -6 plus the v So 10 and negative 12. So that gives us 8 and negative 15. Of course, if we use the calculator, we can utilize the list option, the list. So we have 2 times second parentheses 5 comma negative 6. So it's just like a vector that has 2 components. Then plus open second open parentheses negative 2 comma negative 3. We close that. 8 negative 15. Right, so that's what we have. Right, next, let A1, A2 be the vectors like that be determine whether B can be written as a linear combination of A1 and A2. In other words, determine the weight x1, x2, so this solution exists. So first we're going to write this vector equation as x1 times the vector A plus x2 times the vector A2 equal to B. Right. Now, if we combine the left hand side, what we have is for x1, 1x1 and negative 2x1, and then add multiple x2 here. So bottom line is the left hand side is equal to 4x1 plus negative 1x2 and then 1x1 plus 3x2 and then negative 2x1 plus 3x2 equal to negative 14, 3, and 12. Right. So 2 vectors are equal if the corresponding entries are equal. So for x1 minus x2 equal to negative 14. x1 plus 3x2 is 3, and negative 2x1 plus 3x2 is 12. Right, so we're going to put that in a matrix. And then we do the reduced to echelon form. Right. There might be a problem here. Right. For negative 1, negative 14, 1, 3, and 3, negative 2, 3, and 12. Right, so that actually there's no problem. I mean, what I was afraid of sometimes it might not work, so we have to add a row of 0 at the end, a column of 0 at the end. If that doesn't work, but this one, it works just fine. So once again, we have this column for x1, this column for x2, and we do have the pivot for x1, the the pivot for x2. So both of them are basic, and we have x1 is equal to -3 and x2 is equal to 2. However, the unique solution. So the answer is determine whether B can be written as a linear combination of A1 and A2. The answer is yes. And if it is the case, determine the weight. So the weight x1 is -3 and x2 is equal to 2. Right. Next, we have the product. Right. So there's a couple ways to do this. The easiest way, just enter everything you calculate and calculate, or we use row times column. But this we also write this as linear combination. So the 6 will go with the first vector, and then -7 the second column, and then 8 the third column. Notice that in here, if we check the dimension, we have a 2 row, 3 column, and then 3 rows, 1 column. The middle numbers are the same, so when we multiply, the outside number give us the dimension of the product. So all we just do this, each number here we multiply by each column. Right, so -48, 18, just going to add here, -7, -56, -8, and 8. So -48, -7, and -8, 48 and 8, 56, -63. I'm just going to check with the calculator later. So 18 and 8, that's 26, that's my 30. Right. So I have 2 rows, 3 columns, and the numbers -8, 1, -1, 3, 8, and 1. Multiply by another matrix 3 by 1. 6, -7, and 8. Okay, so we're good. Right. Next, write the system as a vector equation or the matrix equation as indicated. So the vector equation, this one, for the first one will be in the vector equation. The second one will be as a matrix equation. Right. Actually, I'm going to use both. First, we have the system of linear equation. So we have here x1 times 3 times 5. So we just write this as x1, 3, and 5. And then factor out x2. We have -5. And then no x2 here. And if we factor out x3, we have -1 and 3x3 equal to 2 and 6. So this is our vector equation. Just for each column, factor out the weights. So this is in the vector form. Right. Next, if we want to put this in the matrix form, remember kind of like what we did earlier, right? So x1, x2, x3 is going to be a column. And we'll just stack the column. As a matrix, so the first number with the first column, the second with the second column, the third with the third column, and combine all of that equal to 2 and 6. Right. So the vector form, this is in the matrix form. Right, next, I'll write the following system as a matrix equation. Right, so first, I'm going to write this as a vector first. So factor out x1 on the first column. X2 on the second column. And x3 equal to -3 and 4. So that is in the vector form. In the matrix form, we're going to stack the weight x1, x2, x3 as a column. And then we have 5, 3, 1, -5, and -6, 0. That is the matrix form. Right. So that's what we have. Right. Next, find the general solution of the simple homogeneous system below, and then give your answers linear combination of vectors. Let x2 and x3 be free. Okay, so we only have one equation as a system. So in this case, the only thing we can see here is all of them are even. So if we divide by -2, just to simplify the equation, right? So we divide by -2 on both sides. That gives us x1 plus 7x2 minus 4x3 equal to 0. Now if we put this in the matrix form, there's only one row. And we have x1, x2, x3. As you see, the pivot is here. So x1 is basic, x2 and x3 therefore will be free. So exactly what we have here. So we say let x1 and x2 are free variables. So we just say let x1, x2 and x3 be free variable, meaning it can be anything. Right, from this equation or this row, what we can get from this is x1 equal to -7x2, -4x3. So the solution is give as the combination of the vectors. Okay, now differently, we have to write the answer as the vector. So let's say if we write like this, x1, x2, x3 equal to x1 now is -7x2 minus 4x3. x2 is x2 and x3 is x3. Now we can split this matrix as and factor out x2. For the first column will be -7, 1 and 0 because there's no x2 here, and then factor out x3, this column will have -4, 0, and 1. So as you see, the solution will be the linear combination of these two vectors, because it is a linear combination with two vectors. So these two vectors in R3, so we have a solution in R3. However, it only have two vectors, so the answer is going to be a plane in R3. So solution is a plane because it requires two parameters. If there's only one vector, that will be a line. Two vector, it will be a plane. And 3 dimension, because this is the vector in 3 dimension. Right. Right, I think I stop the first video here, and now we pick it up from another video.